Hello, I'm Richard Patterson and welcome to another science video presented by IPC Irwin. And in this episode we're going to look at the IPC Irwin vibration generator and its accessory kit. So we're going to use the vibration generator to recreate a very famous experiment from 1860 by the German scientist Franz Melde. And he didn't have a vibration generator like this in his day. This graphic shows how he achieved some of his results using a tuning fork. But we can do it a little more efficiently. And what we're going to do is use the IPC Irwin vibration generator, which is essentially the driver from a loudspeaker, and it's coupled up to the signal generator and amplifier. And we're going to pass a low frequency AC signal through the coil of this, which will cause this actuator to vibrate and pass those vibrations along the string. The string is kept taut using some small masses with this pulley here. And this close-up shot shows you we need about 60 grams on the end to tension it to get some good results with this setup. So I've connected up the vibration generator to the 4 ohm output here, and we're going to now switch the signal generator on, and the vibration generator will recreate the noise as well. It acts as a loudspeaker resting on the bench here, and we've got to make sure that the unlock is off there on the machine. So I'll switch it on and the actuator starts moving, and that's going up and down at about 9 Hertz. So I'll slowly increase the frequency, and what we're going to do is look at the string and look out for nodes and antinodes. Now, if you remember, a node in a vibrating string is a place where there's no displacement at all, and antinode is where there is maximum displacement. Because we're going to create a standing wave in this string, the vibrations produced from here are traveling along the string and then reflecting back, and we'll get constructive and destructive interference, which will cause the node and the antinode. And you'll see in the graphics showing the mathematics for this experiment that by measuring the length, the distance of the nodes and the antinodes along the string for different frequencies, and also working out the mass per unit length of our string here, we can finally work out the velocity of the wave travelling along the string. So we'll watch now as we increase the frequency, and we'll look out for the first period of a standing wave, which we call the fundamental. You have to just go up and down a little bit to see it. So I hope you can see there that we now have reached the fundamental mode of vibration of this string, which is called the first harmonic. We have a strong antinode in the centre and nodes at either end. And if you use a meter rule to measure the distance of the antinode, the maths in the graphic that follows will show you how we can calculate the velocity. I'm now going to increase the frequency and try and find the second harmonic. That's a little more stable. So we now have second harmonic there, and in the center there the string isn't vibrating. We have a node caused by vibrations reflected from the pulley coming back to meet the vibrations coming from the vibration generator, and at this point here we've got perfect destructive interference the two waves cancel each other out, so we have a position on the string which isn't actually moving. We'll now try and increase the frequency a little more to get the third harmonic. So I hope you can see now that we've got 2 points where the string isn't moving. We'll try and find the fourth harmonic. As we go up through the harmonics, the maximum amplitude gets less, and eventually we can't discern any of the higher harmonics. We've reached the upper limit there on the frequency generator, so I'll reduce it and go at one range. We can use the IPC Irwin stroboscope to get a better view of the nodes and the antinodes on the stretched string, and for that you're going to have to darken your teaching space. The vibration plate apparatus allows us to show standing waves in these three different lengths of plates. So to use them, we just take off the plug that we've used for the string and put that onto the actuator there of the vibration generator, and then set the signal generator to a very low frequency. As we increase the frequency, we should see resonance in each of the three strips at different frequencies. The second accessory that comes in the kit is the Chladni plate, and again remove the plug from the actuator and place the plate there, and there's some very interesting resonance patterns in 2 dimensions when we sprinkle light particles such as salt on the plate. So thanks for watching this episode on the vibration generator from IPC Irwin. As ever, you can go on the Institute of Physics Spark site and look at episode 324, and you've got all the teaching details there. And if you go on our IPC site, shown in this QR code here, you can find out all the details about this apparatus.